Hey guys, Miss Miklos here, and in this lecture we are talking about special right triangles. And you guys did learn about this a little bit in geometry, but we're going to be using them in a slightly different way. And I want to start off by stressing how important this lecture is. These are ratios and values that we use again and again and again. I think in pre-calculus we use these in like 4 or 5 different chapters. And this year we are going to use them in some upcoming things in chapter 14. So we definitely need to have these values down. So we have 2 special triangles. Our first one right here, you guys may have heard this called an isosceles right triangle or a 45-45-90. And we are going to call the sides opposite from 45's ones, and my hypotenuse is radical 2. So this is something you guys should have memorized, that across from the 45 degrees are ones and our hypotenuse is radical 2. My other special triangle is a 30-60-90 triangle. And opposite from 30 degrees it is 1, opposite from 60 degrees is radical 3, and my hypotenuse is 2. So once again, this is another triangle that I need to have memorized. And the way that we're going to see these problems, it is going to tell us to find the exact value of sine of 30 degrees, which means that I am not using my calculator. So we're starting off with a really easy one here, but I'm going to go ahead and sketch this out. I know 30 degrees is in quadrant 1. Okay, so just so we're aware of what this means, that's telling me that this is 30 degrees away from our positive x-axis. So that means that my reference angle is 30 degrees. And a key thing you guys are going to see throughout this lecture today is that the reference angle is going to be equal to how far away are you from the x-axis. So in quadrant 1 it's pretty easy. This is evident we are 30 degrees away. That means that my other angle is 60 degrees. So I know that my opposite side from 30, and this is what we need to have memorized, is 1. My adjacent side is radical 3, and my hypotenuse is 2. It would make sense that this is positive because it's moving to the right. This length is positive because it's moving up. And I know that our hypotenuse is always positive. So if I'm finding the sine value, I know that sine is opposite over hypotenuse. So I'm going to say sine of 30 degrees is 1 over 2. And that would be my answer. So we are kind of combining these two concepts of my special triangles along with SOHCAHTOA. So let's do another pretty basic one here. I have cosine of 45 degrees. So if I'm drawing out 45 degrees, I know that means my reference angle is 45 degrees because this is 45 degrees away from the x-axis. My other angle, my other acute angle would also be 45 degrees, so that means those lengths would be 1, and my hypotenuse would be radical 2. And once again, this is because I have this information memorized. So if I'm finding cosine, I know cosine is adjacent over hypotenuse. So I would say cosine of 45 degrees is adjacent over hypotenuse, or the way that we see it written quite frequently would be radical 2 over 2. Okay, so the key thing here is I'm figuring out what quadrant is this angle in, and I'm drawing it in that appropriate quadrant, figuring out what our reference angle is, and labeling the sides accordingly, then using this trig ratio to determine what 2 sides am I making a fraction out of. Number 3 is another pretty easy one here, tangent of 60 degrees. So once again, I know 60 degrees is in quadrant 1, so I'm going to draw an angle in quadrant 1. And it really does not matter if my triangle is to scale. Okay, I just need to be able to draw it in the correct quadrant. I know that means this is 60 degrees, which means my other angle is 30. This time, opposite from 60 degrees is the side length of radical 3. My adjacent side is 1, and my hypotenuse is 2. I know tangent is opposite over adjacent, so I would say tangent of 60 degrees is radical 3 over 1, or just radical 3. Okay, so when we are in quadrant 1, it quite honestly doesn't get a ton tougher than this. You can imagine things that might get more difficult is this could be in radians instead of degrees, where I would have to go ahead and convert it into degrees. We might also have one of our reciprocal functions instead of sine, cosine, or tangent. But for the most part, this is all we need to be able to do. So some of you guys are thinking, oh good, this is super easy, there's not that much work to do. And when we're in quadrant 1, you guys are right, but we get to number 4 here. And all of a sudden I have cosine of 225 degrees. So I need to think, first of all, what quadrant is 225 in? And I know that that is in quadrant 3. Okay, so this is 225 degrees. So obviously, I know that this angle inside our reference angle is not 225 degrees, because that makes 0 sense, because I know all 3 angles have to add up to be 180. So the key phrase that we said we were going to ask ourselves was, how far away are you from the x-axis? And I know that the x-axis, the closest x-axis here is 180 degrees. So to figure out this value, I'm going to take 225 and subtract 180, and I get 45 degrees. And a little hint to you guys, we should always end up getting either 30, 45, or 60, and if not, you probably did something wrong, because otherwise it's not one of our special triangles. I know that means if our reference angle is 45 degrees, my other angle has to be 45 degrees as well. Now what's going to be different in this triangle is I have sides that are going to the left and going down. So instead of 1 and 1, I know this is going to be -1 because it's moving to the left, and -1 because it's moving down. My hypotenuse is radical 2 because we know the hypotenuse is always positive. Once I have my triangle drawn out, now I just need to focus on cosine. So I'm going to do cosine of 225. Cosine is adjacent over hypotenuse, which is -1 over radical 2, which I would write as negative radical 2 over 2. So the only thing that is going to be a little bit different when we're in a different quadrant is based on this angle, I need to figure out what is our reference angle, which is really answering the question, how far away are we from the closest x-axis? The other thing that it affects is if our side lengths are positive or negative. Number 5 says tangent of 3 pi over 4, and I'm going to start by converting this into degrees. So I end up getting the tangent of 135 degrees. So I'm going to go ahead and draw this. I know 135 is in quadrant 2, so I need to think, how far away is 135 from the nearest x-axis, which is 180? And I realize that 180 minus 135 is 45 degrees. So we have another 45, 45, 90 triangle. This time my opposite side is going to be +1 because it's going up. My adjacent side is -1 because it's going to the left, and my hypotenuse is radical 2. So if I'm finding tangent, I know tangent is opposite over adjacent. So I do tangent of 135 is 1 over -1, or just -1. As you guys get good at drawing these triangles, you should be able to do a problem like this in about 15 seconds. Because what we will find is that once we get into some tougher problems, this is just one little piece of the overall problem. It's not the only problem we have to solve. So let's make it tricky now. Number 6, I have secant of -60 degrees. So if I wanted to, I could make a positive coterminal angle, but I'm okay knowing that -60 degrees is in quadrant 4 and it is 60 degrees away from the x-axis, and that would be 30 degrees. So my sides would be negative radical 3, 1, and 2. Now this time I have secant. I know secant is the reciprocal of cosine, so that would be hypotenuse over adjacent. So I would say the secant of negative 60 degrees is 2 over 1, or I would just say the secant of negative 60 degrees is equal to 2. So when we have negative angles, remember the other thing I could have done is I could have figured out that that was the same as 300 degrees. And if I had 300 degrees, how far away is 300 degrees from the nearest x-axis? Well, this is 360, so 360 minus 300 gives me 60 degrees. So either way I think about it, I end up getting the same exact reference angle. Having this reciprocal ratio didn't change anything. I just had to remember what two sides we were finding the fraction of. So I don't know if you guys noticed, but we were getting a lot of the same answers again and again and again. And what I just went through on those first 6 problems was really the first way that we can use to solve these. I actually prefer the method I'm going to talk about right now, which is just using memorization. So there are actually 9 trig functions we need to have memorized. Sine of 30 degrees is 1/2. Cosine of 30 degrees is radical 3 over 2. And tangent of 30 degrees is radical 3 over 3. Sine of 60 degrees is radical 3 over 2. Cosine of 60 degrees is 1/2. Tangent of 60 degrees is radical 3. Sine of 45 degrees is radical 2 over 2. Cosine of 45 degrees is radical 2 over 2. And tangent of 45 degrees is equal to 1. And these 9 trig functions, I personally think you should have memorized. I would make flashcards or something just so you can really drill these into your heads. Now, obviously, not all of our angles were 30, 60, and 45. We had some angles that were in different quadrants. So because of that, we need to remember our saying, all students take calculus. So just to review, that meant that in quadrant 1, all trig functions were positive. In quadrant 2, only sine and obviously cosecant were positive. In quadrant 3, tangent was positive. And in quadrant 4, oh, that was rough. Let me redo that there. In quadrant 4, cosine is positive. So basically, if I can determine what the reference angle is, I can use those 9 trig functions that we memorized and then look at the quadrant to determine if something should be positive or negative. So why don't we go ahead and practice some problems using this method. Okay, so tan of 225. I know tan of 225. 225 is in quadrant 3. The other thing that I can determine is that 225 is 45 degrees away from the nearest x-axis because it's 45 degrees away from 180. So if I have this memorized, I know tan of 45 degrees is 1. And I need to think, in quadrant 3, should this tangent value be positive or negative? So I'm thinking all students take. Quadrant 3 is take, so that means tangent is positive. So my answer would just be 1. So as we can see, this is a much quicker way to go about doing it, but it really relies on the fact that I have all of these 9 trig functions actually memorized. So in our final example here, let's do sine of 300 degrees. I know 300 degrees is in quadrant 4, and I need to think how far is 300 from the closest x-axis, which is 360. So that tells me it is 60 degrees away. So I need to figure out, okay, sine of 60 degrees is radical 3 over 2. And in quadrant 4, I know it is all students take calculus. So that means cosine is positive, which makes everything else negative. So my ratio would be negative radical 3 over 2. So for your homework that corresponds with this lecture, you guys just have a lot of practice on this concept. You guys will have a quiz next class where it's a timed PowerPoint quiz where you guys will have questions like this and you will have 15 seconds to go ahead and answer them. So that means that you need to know these values off the top of your heads.